Amazon Web Services, better known as AWS, entered the AI chip market with two main products, Trainium and Inferentia. These chips are designed to reduce reliance on external suppliers like NVIDIA and make large-scale AI workloads cheaper for companies running on AWS. Trainium is built specifically for training large AI models. Training is the stage where a model learns patterns, and it requires huge computing power and massive energy consumption, so cost efficiency matters a lot. Amazon claims Trainium can deliver up to 50% better price performance compared to traditional GPU-based training in certain workloads. Inferentia focuses on inference, the stage where trained models actually respond to user requests. This includes things like chatbots, recommendation systems, and AI-powered search results. Since inference runs continuously and at scale, efficiency becomes even more important. What makes Amazon's strategy interesting is that these chips are deeply integrated into AWS. Instead of selling hardware directly, Amazon provides access through cloud services. Companies renting computing power can choose these chips as an alternative to GPUs, often at a lower cost. This cloud-first approach has helped Amazon deploy AI hardware quickly. Large companies already using AWS infrastructure can switch to Trainium or Inferentia without rebuilding their entire systems. That convenience is a big advantage. However, when it comes to raw architectural innovation, Amazon's chips are more evolutionary than revolutionary, and this is where Cerebras enters the conversation. Cerebras took a completely different path. Instead of designing a chip similar to traditional processors, the company built something called the wafer scale engine. Rather than cutting silicon wafers into smaller chips like most manufacturers do, Cerebras uses an entire wafer as a single processor, and the result is enormous. The latest Cerebras system contains hundreds of thousands of AI cores on one chip and massive on-chip memory designed specifically for deep learning workloads. This architecture removes many of the communication bottlenecks that slow down traditional GPU clusters. From a technical perspective, it is one of the most ambitious hardware designs in the AI industry. Cerebras systems are extremely specialized and expensive. They are mainly used in research institutions, government projects, and high-end AI labs. While they can deliver impressive performance for certain workloads, they are not as widely deployed as cloud-based solutions like AWS, and this is where scale matters. Amazon has thousands of data centers around the world and millions of cloud customers. Even if its chips are not the most advanced in architecture, the sheer size of AWS gives them massive real-world adoption. But Google has been building custom AI chips longer than both Amazon and Cerebras. Its tensor processing units were first introduced in 2016 and have gone through several generations since then. Unlike many companies that retrofit general-purpose hardware for AI, Google designed TPUs specifically around machine learning workloads from the beginning. The reason is simple. Google runs AI everywhere. Search, translation, YouTube, image recognition, spam filtering, and large language models all depend on machine learning. Running these services efficiently at global scale forced Google to rethink traditional chip design early on. Modern TPU clusters are extremely powerful. Google connects thousands of TPU chips into specialized pods that work together as a single AI supercomputer. These systems can train some of the largest AI models in existence. But hardware alone isn't what gives Google its edge. The real advantage comes from the tight integration between hardware, software, and infrastructure. Google designs the chips, builds the data centers, and controls the AI frameworks like TensorFlow and JAX that developers use. Because everything is optimized together, the entire stack runs more efficiently. In many ways, this vertical integration is what sets Google apart from competitors. Amazon excels at cloud deployment and infrastructure scale. Cerebras pushes the boundaries of hardware architecture. Google combines both strong hardware design and a deeply integrated AI ecosystem. Amazon's chips are practical and cost-focused. They are built to support AWS customers and reduce dependency on NVIDIA hardware. For many companies already operating inside the AWS ecosystem, they offer a convenient and efficient solution. Cerebras represents a bold technical experiment. Its wafer-scale processors show how far AI hardware design can go when engineers rethink the traditional limits of chip manufacturing. Google, however, currently holds the strongest position in overall AI hardware maturity. Years of experience building TPUs and integrating them into global AI services have created a powerful ecosystem that is difficult for competitors to replicate quickly.